Alright, hello everyone. I hope all of you are doing great. So today we have this Leetcode Biweekly Contest, and I was enjoying my weekend at home, so I thought let's give this a try. Earlier in the day there was also an art coder round which went pretty well for me, and I actually became blue, which I'm just realizing. So yeah, that's awesome. So I'm hoping to continue with that in this round. So yeah, let's start and let's hope that I can do well. Still waiting for the round to load. Okay, here we go. Let's start with the first problem. Alright, so given a zero indexed array nums, determine whether there exist two subarrays of length 2 with equal sum. Note that the two subarrays must begin at different indices. Okay. So this one's pretty easy. I think we can just create a map. Right. Cool. So let's say n is equals to nums dot size. So we'll keep a map of all the sums that we are getting. Okay, so for I is equals to n minus 2, I is greater than equals to 0, I minus minus. So if mp dot find nums of I plus nums of I plus 1 is not equals to mp dot end, then we'll just return true, right? Otherwise we'll do mp of, so this should be mp nums of I plus nums of I plus 1 plus plus, something like that, and finally we can just return false. So we are getting true here. Let's just run all the tests. Okay, this thing is like pretty irritating for me. So we're getting true, false, true, which is correct. So let's submit this. Cool. Let's move on to the second problem. So an integer n is strictly palindromic if for every base b between 2 and n minus 2, the string representation of the integer n in base b is palindromic. Given an integer n, return true if n is strictly palindromic and false otherwise. Wow. I think this is just brute force, right? Yeah. So base goes from 2 to n minus 2, right? Okay. So what we have to do here is we can iterate for the base from 2 to n minus 2, right? So for int base equals to 2, base is less than equals to n minus 2, and base plus plus. So what we'll do is we'll try to we'll try to create this and check whether it is palindrome or not. So let's create the string s, and int n1 is equals to n. So this is just a copy of n, and now while n1 is greater than 0, what we'll do is we'll concatenate to the string. Okay, so there is one more problem here, that the numbers can be big, right? So I mean the base can be big, so we can't just simply take these remainders like this. So that's an issue. So let's see how we can resolve that issue. So let's say that my base is 15. Then what happens is if the remainder of n with 15 is 14, then I will have to put 14 here, right? Yeah. Okay. So that means I have to create a vector of strings, let's say. Yeah, I think we can do that. Cool, no problem. So what is the remainder? So remainder will be n1 mod base, right? So we will create a temporary string which is like toString of remainder, right? And then we will just reverse it and concatenate it, right? For example, if there was 14, we would first do 4 and then do 1, right? So we'll reverse it and then we'll concatenate it. Right, so we'll do s plus equals to temp, then we'll create s1 equal to s, then we'll do reverse of s1 dot begin s1 dot end. So this is just to check whether s is a palindrome or not. So if s is not equal to s1, then we can return false. Right, let's see this is working or not. Oops, so this will definitely TLE. I also have to do n1 by equal to base, right? Cool. For 9 we are getting false. For both of them we are getting false, so just let's check once. So let's say we were getting number 14, so what will we do? We are constructing the string in reverse order, right? Yeah, I think this is correct. So for 14 we'll do 41 and then when we'll reverse. I think this is correct, so let's submit this. Cool. Okay, moving on to problem 3. So you are given a 0 indexed m cross n binary matrix, m cross n, and an integer calls which denotes the number of columns you must choose. A row is covered by a set of columns if each cell in the row that has a value of 1 also lies in one of the columns of the chosen set. Return the maximum number of rows that can be covered by a set of calls. Okay. What are the constraints here? Yeah, so both m and n are small. So basically we can represent each row by a mask here, right? Yeah. So there are n columns in each row, so each row is a binary mask of size n, and a row is covered if it is a subset of it, right? Yeah. So we can iterate over all the masks which have the built-in pop count of calls, and basically we can find out the number of subsets of this particular mask, and then we can maximize that. Yeah, I think that's it. Cool. So int nij nm. So n is the number of columns, which is equal to, I think we can just keep n as the number of rows, so it's mate dot size, and m is equals to mate 0 dot size, which is the number of columns. So now we will have a mask, so all the masks lie in the range from 0 to 2 raised to the power m minus 1. So vector int count. Cool. So now we will go over all the rows and we will generate the masks, right? I is equals to 0, I is less than n, I plus plus. For j is equals to 0, j is less than m, j plus plus. Okay, so if aij equal to 1, so what we'll do is we'll initialize a mask variable which is initially 0, and if this node if this cell is 1, then we will just do mask plus equals to 2 raised to the power j. So finally we have our mask, so we will just do count of mask plus plus. Cool. Now what we'll do is we'll iterate over the subset that we are choosing. So int mask, let's say. So for mask is equals to 0, mask is less than 2 raised to the power m, and mask plus plus. Cool. So if the pop count of mask is not equal to calls, then we don't really need this. So I hope this built-in pop count function works in Leetcode. So if built-in pop count of mask is not equal to calls, then we can just continue. Let's initialize an answer variable with 0. Finally we have to return this answer. Cool. And now we will go over all the subsets. So let's keep it mask2. So mask2. So mask2 is equals to, so what is 2 raised power 24? I hope that's okay. Yeah, it won't be 2 raised to power 24 anyway. So mask2 is equals to 0, mask2 is less than 2 raised to the power m, and mask2 plus plus. So now we want mask2 to be a subset of mask1, right? So basically the bitwise AND of mask2 and mask should be equal to mask2 only. Then and only then it will be a subset. So then we initialize a current variable by 0 and we will increment current by count of mask2, and then we will maximize the answer with cur. Right, so let's just get rid of all the compile errors. Of course, this should be mate. Is this stealing? Oh wow, that shouldn't happen. Okay, why is that even happening? Okay, let's just keep this as mask and now try to run it. Okay, this is giving the wrong answers. Let's see why that's happening. Made 0 dot size, count 1m0. So mate ij has to be equal to 1, so we will just say mask plus equals to 2 raised power j, then count of mask plus plus. Cool. So now we will iterate for the first mask. If its built-in pop count is not equal to calls, we continue. We say that cur is equal to 0. Okay, so this should be mask 2. That's the problem. Less than equal to mask. Now let's check this. We are getting 3. I think that's correct. Let's just check for all the tests. 3 and 2. Let's submit this. Cool. So we're done with 3 problems. Let's focus on the last problem now. So you have n robots and you are given 2 zero indexed arrays, charge times and running costs, both of length n. Okay. Now the ith robot costs charge time of I units to charge, and it costs running costs units to run. Okay, so you are also given an integer budget. So the total cost of running k chosen robots is equal to maximum of charge times, makes sense, plus k times the sum of their running costs, right? Yeah, makes sense. Return the maximum number of consecutive robots that you can run such that the total cost does not exceed budget. Okay, makes sense. Yeah, this is a really nice problem. I think we have to do this somehow in O of n log n or O of n. So I'm thinking we can use like a monotonic stack to create the next greater element to the right and the next greater element to the left, and then we can iterate on which element is having the maximum charge time, right? Yeah. Maximum number of consecutive robots that you can run such that the total cost does not exceed budget. Or maybe we can do a binary search here. We can fix the number of consecutive robots that we want, and in O of n time we can calculate all these values for every starting point, right? So we would need to have the maximum element in the range from I to I plus k. That can be found out using a sparse table, right? So in O of n log square in time we will be done. But what I'm interested in is there something better here? How do we find the maximums quicker? We can use a segment tree, but that would be even slower. So I think a sparse table is the way to go here, right? And then we can just do binary search. Cool. Let's implement that. Right. So for that, first of all, we will need a prefix sum array, and we will need a sparse table array, right? So cool. So let's just build them. N is equals to charge times. Let's just create two other arrays, A and B. A is equals to charge times, and B is equal to running costs, just so that I don't have to write it down again and again. Yeah. So we need to build the sparse table on charge times and the prefix sum on the running costs, right? So vector, so n is equals to a dot size and vector int prefix sum, which is n and 0. Cool. Now let's build the sparse table, or let's just first build the prefix sum. So for I is equals to 0, I is less than n, I plus plus. So p sum of I is equals to a of I, sorry, b of I. We need to build the prefix sum on the running costs, and if I is greater than 0, then p sum of I plus equals to p sum of I minus 1. Cool. So now it's time to build the sparse table. So we will build it vector of int. Let's call it dp. That's just something that I like to call it. And since n is not exceeding 5 into 10 to the power 4, let's keep it of size 15, I guess. No, 18. Yeah, let's do that. So 19. So vector of int dp of size n, and here we have vector of int of size 19 initialized with zeros. Cool. So I is equals to 0, I is less than n, I plus plus. dp of I 0 is going to be nothing but a of I, right? So we need to build a sparse table on a. Cool. So now let's just create a variable j. So for j is equal to 1, j is less than 19, j plus plus, and for I is equals to 0. Now what we want is that I plus 2 raised to the power j minus 1 should be less than n, and I plus plus. So this is just how I remember to implement a sparse table, because if a subsegment is starting from I, it will end at I plus 2 raised to the power j minus 1. Cool. So dp of ij, since we need the maximums, would be maximum of dp of I j minus 1 and dp of, so now this is going to be what? I plus 2 raised to the power j minus 1, right? So dp of I plus 2 raised to the power j minus 1, j minus 1. I think this will work, right? So I j minus 1, and the starting point of the next segment is going to be I plus 2 raised to the power j minus 1 and j minus 1. Cool. So this makes sure that the sparse table is also correct, and now we can do a binary search, right? So L will be 0 and R will be n plus 1, because we can always do this with 0 robots, right? So then we can just do a binary search while R is greater than L plus 1. Now mid is equal to L plus R by 2. So we will iterate from 0 to n minus 1, and we will try to do it for a segment from I to I plus mid minus 1. So for I is equals to 0 and I plus mid minus 1 is less than n, I plus plus. Now we will check whether we can do it for this segment or not, right? Let's say we check this. So if we are okay, then we'll say L is equals to mid. Otherwise we'll say that R is equals to mid, and finally we are going to return L. So how do we check this now? So we need the maximum element in the range from I to I plus mid minus 1 and the sum in this range. So let's initialize L1 and R1, right? So L1 is going to be I and R1 is going to be I plus mid minus 1. And okay, damn it, I'm using LL everywhere. This should be int. Yeah, cool. So let's have another variable length. Length will be nothing but mid, right? So now we need the maximum in this range. So we need the greatest power of 2 less than that. So let's have another variable power of 2, which is 31 minus count leading zeros of length. So this will straight away give us the smallest power less than or equal to 2. And now we want to query for the sparse table. So int mx is equals to maximum of, so the first query is going to be dp starting from L, and the second index is going to be power of 2, and the basically we want to find the second starting point, and that would be something like this. So we want basically L plus, so we want x plus 2 raised to the power this minus 1 to be equals to R1. So x is nothing but R1 minus 2 raised to the power something plus 1, and then we again do power of 2. So this will give us our maximum using the sparse table that we just made, right? Okay, cool. And now we also need the sum. So int sum is equals to prefix sum of R1, right? Okay, so this should be L1 not L, and if L1 is greater than 0, then sum minus equals to prefix sum of L1 minus 1. Cool. So now what do we want? We basically want yeah, so we want k into the sum of the running costs. Your max time is the sum of the running costs. Okay, I just forgot about this k here. I don't think this will cause any problems, but it's pretty useless to keep it here. But anyways, let's have it. So the value that we want to check is mid times sum plus mx. So if it is less than or equal to the budget that we have, oops, so this is long, that's not a problem. Let's just hash define ll long and convert everything to ll. Yeah, ll, yeah. So now this value should be less than or equal to yeah, that shouldn't be a problem. Yeah, so this value should be less than or equal to the budget that we have. Then we'll just do OK equal to true, right? Cool. Now let's just get rid of all the compile errors. Ah, damn it. Can we do something like this? I'm not really sure. Damn it. Okay, no problem. So A will be of size n, right? So n is equals to charge times dot size, and so both of them will be of size n. I is equals to 0, I less than n, I plus plus, ai is equals to charge times of I, and bi is equals to running costs of I. Okay, now that shouldn't be a problem anymore. Ah, damn it. This should be LL. This is the problem with Leetcode for me, at least. You know that I make a lot of compilation errors because I'm used to coding with my template, right? 3 and 0. So let's try and submit this. Cool. So yeah, we are finished with all the problems, and it took us around 25 minutes. So let's have a look at our rank. Shouldn't be very great, I guess. 275, I think, not very bad. So yeah, I think I'm going to stop recording now. It was a pretty well balanced contest, I think. So yeah, thank you so much for watching.